This is the editing your data online and offline with the ArcGIS Runtime. It's really one in a series of 3 workshops that we have going on this week. This one's specifically about editing your data. We have another one tomorrow, which is about just working with your maps offline, and it has a lot more about the data workflows. And there was a demo theater yesterday afternoon about preparing your data. So this is going to focus very much on the editing specific piece. It was meant to be 2 of us up here, but unfortunately, just late last week, Nick Forness had something come up and he couldn't be here, but he has recorded a few videos for the demos that he was going to do. So it's me in person and Nick virtually. They're going to be doing this workshop. So what are we going to cover? We're going to cover a little bit about the infrastructure and what's going on behind the scenes when it comes to editing. We're going to have a look at the API that you'll be working with. And it doesn't matter which public API of the runtime you use, the logical concepts are exactly the same. The capabilities are exactly the same. So it doesn't matter if you're a .NET developer or an iOS developer, Java, Qt, or Android. This is all very, very relevant to you. There's a little bit of updated functionality in the last couple of releases, so we'll make sure we cover what's really new. And what we don't really cover is this data distribution, and that's more the focus of tomorrow's presentation, working with your maps online and offline. So our ArcGIS Runtime sits on top of ArcGIS. It specifically in the workflows and the use cases that we're really going to focus in on today, the editing workflows, it sits completely on top of this geo-information model. It's the information model of the WebGIS. And so that starts with maps for 2D and scenes for 3D, and then it's layers. So it's maps and layers, and these layers are all backed by services, but typically you don't work directly with the service. You work with the layer within the API. That doesn't mean to say you can't work directly with the service. They're all REST services. They're all available to you. But we put a lot of effort into the API to try and make it as easy as possible for you to consume and work with these services. And in particular, you're going to be working with feature layers and feature services when you're editing your data. So what can you edit with the runtime? Well, you can obviously edit feature services. You can edit what we refer to as sync-enabled geodatabases. Where do you get these? Well, you get these from a feature service. That's what happens when you take a feature service offline. You can work with feature collections. These are collections of features that are stored inside of your web map or as a separate web resource that you can reference from within your web map. You can also edit shapefiles and geo packages, but most of what we're talking about today are to do with feature services. All of these inherit in our object model from a base class called FeatureTables. And FeatureTables offer some fundamental capabilities, but it's not a concrete class in its own right. All of these different data sources have their own representation of a concrete class. And we'll have a look at the object model in a little bit more detail in a few slides' time. So how do you, one of the workflows, editing online. And editing online has a lot of the capabilities that you'll use when you're editing. And how do you start doing that? Well, the first thing you've got to do is you've got to create a map, or you've got to create a feature service, and you can do that from within the developer's website. You can do it within arcgis.com using the map viewer, or you can do it in desktop. You can use ArcGIS Pro, you can author your map in ArcGIS Pro, and you can publish that to online or your enterprise server, and you can enable it for editing, and now it's available as a hosted service on your server or within the cloud, and you can start editing it. So what happens on the runtime client, it's retrieving the features as and when the client asks for them. So typically that is happening when you're panning and zooming around the map. But there's 3 different modes that you can use to retrieve your features. You can leave it on automatic, which is the default, which just goes and grabs the features as it's needed to draw them on the map. You can go into snapshot mode, where you go and grab features of all for a specific area in one go. There's another mode which is kind of a combination of these two. But typically just allowing the client to just retrieve the features when it's drawing them, it suits most use cases, because let's face it, when you want to edit a feature, you've probably drawn it in the first place. So you make edits to these features, and while you're editing them on the client, they're in memory. They're not being saved back to the service until you call apply edits, and that's when the features are pushed back to the service. Now, because of things change on the client, we wouldn't recommend caching things locally without calling apply edits for a long period of time. Typically, you'll make one edit and immediately apply it back to the server. You may make 2 or 3 edits, and for optimization purposes, apply them back. But I wouldn't wait too long, because you're working in environments where you don't always have control of the application. On the mobile devices these days, your application might get backgrounded, and the OS might just decide to shut it down. Well, all these cached edits will then be ignored and thrown away. So I would definitely recommend applying edits back to the service on a regular basis. Probably after every single edit would be a good thing. All right, so we've got our first demonstration from Nick. Let's get this going, and I might have to play around with the volume so you can all hear it.
So let's begin by looking at editing a connected feature service. That's a feature service hosted in ArcGIS Online or in your enterprise or server somewhere. So we've got a map, it has a couple of features on it. When I tap on one of these features, I see a little call out. I'm going to click on the accessory button. I'm going to change the type of this feature by picking it in the call out. You can see that edit was successful and the feature changed. Let's just do that again real quick. We'll change it to major. You can see how the symbol changes there. So that was editing directly against a feature service. So let's take a look at the code behind this. So here I've got a sample iPad app, and there's a few components here I want to talk about. The first bit, we just add the feature layer to the map pointing at this feature service. So we create a feature table of a type of service feature table that points at a feature service. We then create a feature layer from that feature table, and we add that to the operational layers of the map. That takes care of displaying everything. And when we tap on the map, we want to make sure that we get hold of that feature that we tapped on and we do something with it. So here we've got a callback from the tap gesture. And here we're just going to identify the feature layer that we created. We're going to see what we were able to identify from the tap point in that feature layer. We can skip these errors and just go and take a look and see, okay, we got a result. I want to show a call out for it, and I'm just going to hold on to that result for use later. In the call out, it's really simple, actually. We're just taking a look at that feature's attributes, and we've got this particular attribute that we're interested in that we know is the type ID for that feature. And we're going to use that in the title. Then we're going to show that call out for the feature. What that means is that when we interact with the call out, we get to know a little bit about the feature as it comes back. But what's more important here is when we select a new feature type from the pop-up that we saw, how we update that. So here we've got a new value for this type damage field, and we're just going to set that. Previously we read it just up here. We read it for the call out, and now we're setting it to the new type that came back from that pop-up. And we simply call feature table update and pass in the feature, saying we've got a new version of this feature, we want to update it in the local cache of that table. And remember, this is the local cache. This table takes care of communicating between the local cache and the remote source service. And that last bit, the communication between the local cache and the remote source service, happens down here. Now, right now, we've updated the local cache and immediately opted to apply that update to the service. You could collect a number of local updates and then apply them all at once. But right now, we're just doing one at a time. And we call feature table apply edits. Now the feature table knows which edits it's got locally, and it just goes ahead and applies them. we get a couple of things back. We have an operation error. This is an overall thing, like maybe the network failed during this connection. We need to check for that. And then there are individual errors that may have happened. In our case, we've only got one update that we wanted to write, but we could have had a collection of them. And so we'd want to know which ones succeeded and which ones failed, potentially. Perhaps they failed for validation reasons, perhaps they failed for other reasons. And so it's a good idea to check that right now. Even if the network allowed the full operation to succeed, perhaps there were some errors on individual updates. And lastly, we just update the UI to show that edit happened okay. So fairly straightforward stuff. Really, the key bit is to update the local feature table and then to apply the edits.
All right. Okay, so let's have a look at that API. And I should say that most of the demonstrations, I think all of them that Nick is showing, he's just using the sample viewer. So the source code that he's showing you today, you can download, and all of our APIs have a sample viewer with all of their samples in it. So you can always just go to GitHub or go to the developer's website and download all the source code. So we have our feature table. It has methods such as add feature, update feature, delete feature, and query features. And a feature table gives you a feature. And it has a back pointer to the table it came from. And a feature inherits from GeoElements. GeoElements are a base class for geometry and attributes. Graphics also inherit from GeoElement, and that allows our pop-up implementation to reuse the same code because they just work against GeoElements, and so pop-ups work for features and graphics. So we've got a feature table is bound to a feature layer, and then we have this ArcGIS feature table. It has a little bit of extra information which is unique to ArcGIS features. So features coming from a geo package, they inherit directly from feature table, not from the ArcGIS feature table. Features coming from a shapefile, they inherit from feature table, not from ArcGIS feature table. But features coming from a feature service or features coming from a geodatabase, they inherit from the ArcGIS feature table, where you can get access to things like their layer info. What symbols am I going to draw the feature with, etc. What templates, what editing templates does this feature class support? We have our ArcGIS feature, which has some enhancements over your basic feature, mainly to do with attachments, but it also follows the loadable pattern as well, so that features, when they come across from a service for rendering purposes, only have the attributes required to support the drawing of these features. So the attributes that the renderers are using. We don't populate all the attributes because it would increase the payload that's being sent from the server and it would slow the fetch down. So when you're editing features, it's important that the features become loaded, and that forces all the attributes to come across from the server. And here you have the two concrete classes finally at the bottom, service feature table and geodatabase feature table. There's very little difference between the two, except on how you actually get the edits back to the server. If you're using the service feature table, you use apply edits. You saw that in the code demonstration from Nick. That pushes my changes back to the server. If you're using the geodatabase feature table, you synchronize your edits, and that pushes your edits back to the server. But most of the code that you write in your application is the same, whether you're working with online features or offline features. So it simplifies your code writing greatly. There's lots of settings that can be made on feature services which will affect your applications when they come to editing them. So you should always be asking, what permissions do I have as the user who's logged into your application? Is the feature layer editable at all? It may not be. It may be set as read-only on the server, in which case you can't make any edits. Or are there individual permissions set on the feature class, which are user-dependent, perhaps? So here you can call can update, passing in the feature, and the editor will perform all the checks and tell you whether you are permitted to make a change to that feature. And so it's always good practice to always inquire if you're allowed to make changes or whether you're allowed to add or delete features before trying to do the action. Because, and we'll enforce these in the API, and if you try and do it and you don't have permission, you'll get an exception thrown in the code. Feature types and templates. These are an extension, if you like, of subtypes, the Geodatabase concept, where it allows you to split your feature class into various types. And for each type, you can actually associate a template. And a template is what we use inside the editor to present friendly names for the type, a default symbol, a default editing tool. All of that gets populated for you. And so you can generate a UI simply by reading these feature templates. Editor tracking can be turned on your feature service. If you turn it on, you can track who's creating features, who's modifying them, and this is all handled internally for you by the API. You don't actually have to do anything. When you turn this on, extra columns are created in the table, but these columns are invisible to you as a developer through the API. If you fetch all the columns on your table, we won't return these ones to you because they're used internally. But they're very useful on the back end to do some auditing and monitoring, maybe some QC work. The ownership-based access control can be turned on. We talked a little bit about how you would interact with that through the API, but it can restrict certain users from doing certain actions. It can allow users to create features and delete features that they've created, but forbid them from changing anybody else's features. So if you're working in a sort of almost like a crowdsourcing scenario where you don't mind people contributing content and changing their own content, but you wouldn't want them changing anybody else's, this is an ideal thing that you can turn on. Again, a lot of this is handled for you inside of the API or inside of our editing widgets. Attachments are supported with the runtime. So typically attachments are these sort of larger files, but they're not just restricted to pictures and video and documents. They can be any file format. And you've got to make sure you've got the upload capability on your server enabled so that the users can actually upload these attachments. But again, there's a whole set of permissions that you need to check before you can try and edit attachments. Can you add them? Can you delete them? Can you modify them? Okay, we've got the second demonstration from Nick, just to talk specifically about how you actually generate geometries and perform geometry edits. You saw attribute editing in the first demonstration.
So in the context of all these capabilities for editing, let's take a look at some of the ways runtime can help, in particular with editing geometries. The runtime includes what we call a sketch editor, and this can be applied to a map and allows interactive sketching of geometries directly on the map. So here we're looking at a point, a simple line, polylines. We can create areas as well, polygons. We can tap on vertices and add vertices to the polygons. Note we also have undo and redo capability built into the sketch editor. We can tap on the sketch itself, rotate it, move it, resize it as we need to. There's even free-form sketch tools, polygons, polylines, and so on. And we can do all this editing with just a very small piece of code. So let's take a look at that code. So right now, we're looking at what it takes to set up the sketch editor on a map. We've created a map, given it an initial viewpoint, and we've set the map view up. And it's quite just as simple as creating a sketch editor and setting the map view sketch editor to that sketch editor. We had an undo and redo and clear buttons in the UI there, enabling and disabling them according to whether we could undo or redo. It's just handled in here. So we set up an observer for when the geometry, the sketch editor's geometry changed, and we just update the UI based off that. And that's all it is really. Create a sketch editor, add it to the map view, and make sure you're observing it for whatever you need to. Then in the UI, when I tap the different types of geometry that I wanted to add, create, this is all it takes. I pick a creation mode based off that UI, and I just do sketch editor.start with creation mode. I'm not passing in an initial geometry because I always wanted to start with a blank geometry in this case. We'll talk about that in a second. And then undoing and redoing is just as simple as calling the undo manager on the sketch editor, calling redo undo, or taking the sketch editor and clearing the geometry if we wanted to clear the geometry. Now, there are a couple of other things that we could do here. One of them is we talked about not passing in an initial geometry, but what if you've got one? Let's say you have a feature there that you already want to pass the geometry into edit. Well, you take the geometry and just pass it in here. We'll mock that up right now with a couple of extra lines of code in here. They're just going to save and restore the last geometries that we used for that particular type of geometry. So I'm just going to copy that in here. And there are other ways that we can configure the sketch editor too. Let's take a look at sketch editor.style. And we have a bunch of different options here. We can change the symbols that we use for the vertices, for the lines. I'm just going to go for a very simple thing and say I want to see node IDs, point IDs as I'm sketching. And so we'll run this again.
And now we see as we add vertices, they're numbered, just with a simple configuration change to the sketch editor. We can still do the same interactions, rotate, and see how the vertex orders are maintained. The other change we made there was to simulate using an existing geometry. So here, as we switch back and forth between the tools, we're providing that initial geometry. Happens to be what we drew last time. It could come from a feature. You could calculate it. However you want to provide that geometry, it's up to you.
Okay, thanks, Nick. All right, so that was all about editing when you're connected to the feature service, but we also support editing when you're going offline. So everything that we've been talking about so far applies when you're editing your content, when you're disconnected from the network. So let's have a look to see conceptually how that works. So again, you can author your map and content in online, or you can do it in desktop and publish it to online. But you basically have that web map that you want to take offline and the data inside of it. You download that to your device, and then you start to use it, and you can start to edit it. And it's all these edits are sitting in a geodatabase that's stored on your device. So if your application closes down and then starts up again, your edits are always persisted because they're being persisted in that geodatabase. We actually use SQLite on the devices as the container for our geodatabases. And then once you get a network connection back again, you do a synchronize. And that's where you can push the changes that have happened on your device to the server, and you can pull the changes that have happened on the server since you took your map offline down to your device. And you've got control on that synchronization. You've got quite a lot of control. You can do bidirectional, where you download things and push things up. That's the most common workflow. But you can also just upload your edits, or maybe you're not editing your data. You just want the most up-to-date map, in which case you can just download the changes that have happened on the server down to your client. So head up straight over for another demonstration here.
So let's take a look at working offline with feature data. As you saw in the last slide, first thing you need to do is download the data. So let's take a look at an example here. Now, this application is currently asking a feature service to generate a geodatabase for use in the runtime. That feature service is collecting together the data in its layers for the particular area of interest, in this case the area we're looking at, packaging it up, making it available to download. So once this data is down on the device, we can do a few things. In the first case, I'm just going to do some editing. So I tap on one of these items and I just want to move it. tap another one of these items, I'll move it. And when I'm done, I'm ready to see these changes synchronized with the service. I'll go and synchronize these. So now runtime is talking back to that originating service again and asking it to synchronize changes that may have happened on the service in the meantime and that have happened here locally on the device, and bring the two into line again. What happens here is the runtime generates a small Delta geodatabase that it sends up to the service. The service incorporates that, similarly generates a Delta geodatabase to send back to the runtime. The runtime incorporates that, and the two sides are in sync. So let's take a look at what that looks like in code. So the first thing we did was set up the map. We had an area of interest, and we initialized the map to look at that and set that up in the map view. That was what we saw initially. We then get a feature server URL. And this time, rather than creating a service feature table and a feature layer from it, we're going to create a geodatabase sync task from it. Now, this sync task talks to that feature URL, learns about the various layers, and understands whether it can be taken offline or not. We then go ahead and generate that local geodatabase from the service. That's done here in this function. We have that geodatabase sync task that was initialized with the URL to the service, and we just called default generate geodatabase parameters. We pass in that area of interest. So the sync task talks to the service and understands the default set of parameters that would make sense for that particular area of interest. And then we override just a couple of things. We don't want attachments for this demo, so we set the return attachments flag to false. Also, there are a number of layers on that feature service, and we only want a couple of them. So we filter that out too. Basically, there's a layer options entry for every layer that we get. And by calling this default generate geodatabase parameters, that's populated for every layer that can be taken offline. What we're doing now is we're paring that down, so it's just for these two layers. Then we go ahead and we say we're ready to download the geodatabase using these parameters. Again, we get hold of that same geodatabase sync task, and this time we create something called the generate geodatabase job. So the task is responsible for generating jobs. We pass the parameters into the task along with a location that we want to download the results of that job to, and we get this job back. We just wire up a little bit of progress bar stuff here, and then we start the job. We'll get periodic status updates if there are new messages from the work that's being done on the remote end of packaging up that data. But ultimately, we get this completion handler called. There could be an error. We've just checked for some errors. But assuming everything worked fine, we actually get a full runtime geodatabase object that's locally stored on the device, ready to use. In our code, we just set that on our geodatabase property, and that happens to trigger this did-set local geodatabase function. In here, I'll take that geodatabase that we've been given and I'll load it. That allows the runtime to understand the contents of that geodatabase. And what we're going to do now is go through all the feature tables in that geodatabase, create a layer for each one, and add it to the map's operational layers. So we'll clear the map first, and then for each feature table in that geodatabase, we'll add a new layer to it. So once we've added the data to the map, we need to talk about editing it. And that happens here in do update edit. And what this is doing is it's taking the selected feature and updating its location to a new point on the map. So we get hold of the feature that we're going to move, we get hold of the feature table, and we check the feature table to see if we can actually update that particular feature. So there's a lot of granularity included here in the API. Assuming we can, we then go ahead and update the geometry on that feature to the new point. And then we call featuretable.update with that updated feature. Now, this is very similar to when we were doing the connected editing, except that right now, that update has committed it to the local geodatabase. There's no apply edits required. But because the local geodatabase is local on the device, we know the performance we can get out of this, and so we don't have to separate the apply edits and the adds, updates, and deletes. And the rest of this is really just a little bit of UI work. Now, the last bit then, we've got this local geodatabase with edits applied, is synchronizing that back against the original service. So we come back to our geodatabase sync task once again. And this time we get default sync geodatabase parameters, passing in the geodatabase we got earlier from the generate geodatabase job. The geodatabase sync task looks at that geodatabase and understands enough about the geodatabase and the service to get a sensible set of sync parameters. Depending on how the geodatabase was generated, there may be unidirectional sync or bidirectional sync. And these default parameters are typically what you want for synchronizing based off how you generated the geodatabase in the first place, but you can override various things. In this case, we're just going to go with the default set of parameters that come back from this call. And we take that geodatabase sync task, and again, we generate a job. Except this time it's a sync job instead of a generate geodatabase job. We pass in the parameters, we pass in that geodatabase. We wire up a little bit of progress as before. And just as before, again, we take this job and we start it. Again, as the progress happens, we'll get periodic status updates. But the key bit is the completion here. And really, we just want to check if there's an error. If there's an error, we need to tell the user about it, do something about it. But otherwise, we can count that the geodatabase that we have locally has been updated, if it was a bidirectional sync, that the data we had locally and wanted to post up has been posted up, all according to the parameters that we set initially. But in this case, it's a bidirectional sync we're doing, and the completion handler signifies that that sync has happened.
Okay, so a little bit more detail on what's happening during that. Where does the data and how does the data flow from the server to your client and then back to your server? So you've got your service, and it's enabled for sync or enabled for offline use. And when you call generate geodatabase, the server creates a runtime or a mobile geodatabase, and you then download that down to your device. You can then perform your edits and your adds and your deletes on that database. And when you want to call synchronize, you call sync. And what actually happens, the database looks for all the changes that have happened and prepares a little delta database, which it then uploads to the server. The server applies the changes that have happened. In some respects, it's just replaying your changes that you interactively made. It's just replaying them against the sort of the real parent database. On completion of that, it generates another little delta database with the response. And the response may have new things that have happened on the server since you went offline in the first place, or it may contain information about failures that have happened on the server. And so it's important that you take that response and you apply it against the local geodatabase to make sure everything gets back in sync. Now, the important thing to stress here is it's very robust, because if at any stage, for instance, once you've got the data on your device, during that call to sync, your device runs out of battery power and stops working, or the network goes down. Whether the network goes down when the data is going to the server, or the network goes down when the data is coming back off the server, it's okay because your data isn't lost. It's either still sitting on your device, or the changes have already been made in the server. But you programmatically, all that you have to do to recover is call sync again. And sync will prepare these changes and send them to the server, because it doesn't know if the server applied your changes or not. It'll send them up to the server. The server knows if it's already reapplied these changes, it won't apply them a second time, and then it will prepare the response and send it back to you. So ultimately, the process will be completed, and you'll get the correct result. And it has to be robust because, as I said before, we work in environments where we are not always in complete control of the network, of the device, of the user's actions. And so the system is nice and robust. Now, this works against version data as well as non-versioned data. Specifically when it comes to versioning, we recommend you create a version for each offline map, and you create a version for each offline user, so that every user who's taking their data offline is there's a unique version backing it on the server, and then you have to do your sort of back-end reconcile and post from the various branches. Clearly, this model doesn't scale to hundreds of thousands of users, and that's where the non-versioning approach is recommended. The non-versioning approach will scale to hundreds of users working offline on your data sources. So what we've been talking about so far with the offline and actually the editing was editing specifically against a feature service. But really what we encourage you to do is to think about working with maps offline, because a map just embodies all your layers and puts them together into one convenient container, and you can work with that offline. So instead of taking all the individual layers off and building up potentially multiple geodatabases, because there's a geodatabase per feature service, you might have 2 or 3 feature services in your map, making up many layers, and you'll end up with a lot of individual geodatabases. You've also got the base maps to consider. Well, if you work with maps, all that work is done for you by the API. So the API will take care of going through the map, figuring out what it's got to do to take things offline, whether it's tiled, raster tiles, or vector tiles, or multiple or single feature services. It'll do all of that for you with one call to the API. And then when you want to synchronize your changes, it's one call to the API, again, to say, synchronize all my changes that have been made on this map to the feature services on that map. And it'll go through and do all the synchronizing one by one. And when you are working offline, there's 2 ways to do that, pre-planned or on-demand. Pre-planned is where you determine ahead of time the areas that can be taken offline, and your users can then come in to work in the morning and take that offline. It scales extremely well for hundreds or even thousands of workers going offline at the same time, because all the data preparations happened. Maybe it happens at 3 o'clock in the morning, and then at 9 o'clock when all your field crews want to take their maps offline, they're just downloading a web resource. There's no load on the server, really. On demand, on the other hand, you're asking the server every single time, prepare me the data for this area and for these scale ranges that I want to go offline with. And so the server has to do some work before these resources are then available for you to download. So it takes a little bit longer, and it puts more strain on the server. It's very flexible, though. So you have your users, you don't need to know where they're going. They can go offline, and they pick the area that they want to use. So different workflows can be used, but if you've got lots of users going offline, we definitely recommend the pre-planned. And the synchronization framework, as I was saying, it works, you can work against the map directly, and we'll take care of connecting to all the different data sources. So that if you're synchronizing layers, they target a single feature service, whereas a map will target all of them. You can choose which layers to synchronize, and that's your choice. Maybe you've got a workflow where it's important that one layer is kept up to date every 30 minutes. Well, you could synchronize the features in that layer and leave the other features maybe for a daily update. It's all possible with the API. So to synchronize a map, we use the offline map sync task. It targets, as it says, every layer in your map. It really does simplify the work that you have to do as a developer. And the offline map task and the offline map sync task, they work together, just the same as the geodatabase task and the geodatabase sync task work together. The runtime geodatabase, just like the other geodatabases, supports editing transactions. Not nested, they're only one level deep, but you can batch up certain operations within a transaction, and then you can commit that transaction, in which case all these changes are made at once, or you can roll it back, in which case the changes are discarded. So I think we've got another demonstration here from Nick. Oops. Here we go.
So the last piece of the puzzle I want to talk about is transactions. When you're working offline with your local geodatabase, you can start transactions and do edits within transactions. You don't have to. You can do edits without transactions. But let's just take a look at that here. Right now, I'm going to be adding some new records to this table here, or to this feature there. So we'll start a transaction. I'm just going to add a couple of records around here. And I can either cancel that transaction or commit it. If I cancel it, it rolls everything back. Go and add some again and commit that transaction. Now let's say I want to add some more records up here really quickly outside of a transaction. And then I start another transaction. I'm going to add some lobsters along here. And now we see when we cancel this transaction, the other work from the previous transaction and the work outside of the transaction before that was started is included. Synchronizing then just happens exactly the same way. The transactions have all been committed locally on the device. When we take a look at the code, we can see the only thing we really need to pay attention to is the current state of transactions. We need to be aware of that as we manage them and create new ones. So here is a begin transaction. If we're in a transaction already, we don't want to begin a new transaction before we finish that last one. And we just call geodatabase.begin transaction. Any updates, adds, and deletes are included in that transaction until we call either rollback transaction or commit transaction. Again, here we check that we're in a transaction before we try to roll back. And likewise here, are we in a transaction before we try to commit it? Those transactions happen locally in the local geodatabase, and then synchronization happens exactly as before.
Okay. All right, so you've written your application and you want to deploy it. And so you need to license it. And so because we're talking about editing, it's being deployed at the basic level. So that's simple feature editing, connected or disconnected. It comes in at basic. Basic also includes authoring maps and creating groups and sharing, but specifically for the topic of this session, it's the simple feature editing that we're after. And so to get a basic license, there's two ways to do that. One way is to purchase a deployment license, a runtime deployment license. They come in packs of a certain number. I think it's 20 or 25 basic licenses cost a certain amount of money. But if you're using WebGIS and you're using ArcGIS Enterprise or you're using ArcGIS Online, you've got users who are signing into their applications. And if a user signs into their applications, they come with runtime capabilities. So if you have a user that's a field worker role, they have the ability to perform basic editing on the features. So you don't actually need to purchase any licenses for runtime. Your users bring the license, their license with them. If they're in the viewer role, which is the entry-level role, that corresponds to light. So they wouldn't be able to perform any editing. So there's a couple of ways that you can license the runtime there. How many people here are using named users and the WebGIS pattern for permissions? A few people. So it's a great opportunity if you're a developer, or even if you're a partner or a developer who's selling applications to existing users or organizations that have ArcGIS. If you're selling them to the WebGIS users, then you have no deployment costs at all. It's the users that are bringing the license to bear. And as Eli showed on the plenary stage yesterday, we actually have an open source data collection application that is available for you to download and use. He was showing it on iOS, but we have the data collection app available for .NET. And very shortly, if it's not already there, it's coming in the next week or so, there'll be an Android open source application as well. And this is a fully fledged, fully working, tested application that you could just use, download, compile, and then deploy to your users without making any changes. And it'll function just nicely. But it does act as a good starting point if you need to do something a little bit extra or maybe a little bit more custom in the workflow. This is a great starting point to do that. Okay, so that's the end of my slides, but I've deliberately left a fair amount of time for questions, because when we've done this in the past, there's always been questions. I didn't want to run out of time. Please remember to take the survey if you can. We greatly appreciate the feedback we get from you. But what questions? There's got to be a few, yes.
It's a question about object IDs.
Mm-hmm.
When I create a feature, it's like in the past, I get a negative object ID until I synchronize it.
Correct. So the question is to do with object IDs, and when you're creating objects on the client, you end up with a temporary object ID, because the real object ID is not going to be assigned to the feature until the object is pushed back to the service, and then you'll get the true object ID. That information comes back in that response packet and will be applied to the database, and that's when you will see the proper object ID. Yep. And they are negative. That tells us that there are these temporary object IDs. Yep. Yep.
I have a standalone ArcGIS server, no portal,
Mm-hmm.
no AGOL. How much of that can I still do?
Okay, so that's a good question. I've got a standalone ArcGIS server, no portal, no ArcGIS Online. How much of what we showed today can you still do? Everything up until the web map piece you can do, because everything up until we started talking about taking a map offline was just about talking to the raw service. So you can definitely do that. When it came to the licensing slide, your application would need a deployment license because it doesn't have a named user. But you can work with your feature services, you can take them offline, you can synchronize them, you get all the benefits of the runtime geodatabase on the client. That all works. It's only when it comes to the web map piece and the licensing with named users, that's the only thing that's unique to portal or online.
Okay. As an add-on to that, you mentioned quite briefly that the version copies are not scalable to hundreds of users.
Mm-hmm.
Can you talk a little bit more about the downsides or I guess the trade-offs of not versioning that offline copy?
Okay, so the question was, I said that the versioned geodatabase doesn't scale as well as the non-versioned branch versioning that we have, the non-versioned sort of archive-enabled database. And what are the downsides of versioning? Is that the question? If you do want to use versioning or you don't want to use versioning?
I want this to be scalable.
Okay, so if you want the solution to be scalable, don't use versioning. Okay. Would be my advice.
I guess what am I losing?
If you don't make versioning, then you're losing the post and reconcile QA QC that you get built in with versioning. So the conflict. That's a question. Actually, we didn't have it in the slides, and I'm surprised nobody's asked a question about it. What's the conflict resolution when it comes to these synchronizers as they get posted back? There is no conflict resolution. Last in wins. So it's very simple. That's one of the reasons why it scales nicely. If you need a QA/QC process, you either need to have a smaller number of people using it, and you can use versioning, and you can still use the reconcile and post from the individual versions, or you need to build on the back end a QA/QC process where you may have a database which the field crews are using, which you then have to QA/QC before you post the replica, if you like, over to the mainline database. So it complicates, if you've got a complicated QA/QC process that you need to, QA/QC process that you need to support, it can add some complexity to the back end, but we've got a number of users that do that. But if the last in wins, it's simple. We typically don't see people having conflicts because they modify their workflows. So they have field crews going out, they're covering different geographic areas, so they're typically not editing the same feature.
Worst comes to worst, you can always have that be an archive service so that you'll get all those versions in there.
You could do that, yes. Yes, you could do that. Anything else? Question here?
If you have a pre-planned workflow, because you have a large amount of data that you want to take offline, is there any way of, when updates happen to the main data, not having to actually move the whole data again?
Okay, that's, yes, okay. So with pre-planned, the question is, if I've got a lot of data and I've created my pre-planned areas, but what happens when updates are coming in? How do these updates get out to the clients? Today, what happens when you create your pre-planned areas, you can set an automatic update frequency when the pre-planned areas get recreated. And at the moment, when that recreation happens, it's a whole new copy of the data that is sitting there on the server, which, if you want the update, you have to download it all again. But we're working on a technology which will be released in the summer, which will just download the deltas. So it'll optimize the update and then you can decide how long you want to just be applying deltas before you say, let's start afresh and just create a brand new fresh copy again. And that's the team's working on putting it into the client for the update 6 release, which will be 2 or 3 weeks after the user conference. Yeah, so that's the Delta workflow that the team's working on.
Are the packages compressed in pre-code? If you have those pre-planned workflow packages, are they compressed for download? Okay,
so the question is, are the packages compressed for download? They're not compressed. Because the packages are not compressed because we seek directly into them for certain of the resources, so we don't uncompress them into multiple files on disk if we can avoid it. So if there are certain cases where if you've got certain data types in your package, we have to unarchive it before we access the file types, because the file readers that we have can't go through the compressed archive. So they're all in an archive, but they're not. An archive is one file. So it's like a zip archive. It's not a zip archive, but think of it like a zip archive, but it's not compressed. Does that make sense?
So it's going to be the size.
It's basically your size of your package is the size of sum of the size of the individual files. Yes.
Okay, so you're saying that there's an issue if you did try, because that's what we've done. I mean, I've written something that creates the package and then compresses it, so that when we bring it across the wire, it's a lot smaller.
We could have an issue depending on how our reading code might not be able to read that. Because it is uncompressed. It is actually an uncompressed zip archive. Question here?
Can you work with more than one map area at a time, either pre-planned or on demand?
The question is, can you work with more than one map area at a time? You can, but in the API, each map area corresponds to a map within the API. So you'd be building an application with 2 map views, looking at the 2 different areas, and that's possible. And you can absolutely swap between them, but you can't. What you can't do is pull down a map area, and then have them both inside the same map view. Yep. Any questions? Question here?
I remember that MMPK rewrite now. Is that accurate? We had a problem about a year and a half ago trying to use those for the pre-planned flow, creating MMPKs and then downloading them, but they were rewriting. So it was only for viewing.
So the mobile map packages that you create in Pro are read-only. And they're still read-only. So the Pro workflow of creating packages, putting them on the devices for read-only workflows. The mobile map packages that the server creates for us are read-write.
So can you automate that part as far as like a nightly job to create those MMPKs in a read-write fashion?
On the server?
Yeah.
Yes. So the following question was, can you automate the creation of these MMPKs on the server? Yes, and that's what the pre-planned workflow does. It actually automates the generation of all these resources every night, or on the time frame that you want. You could do it daily, you could do it hourly, you could do it weekly. It's up to you. Any other questions? Yes, question at the front here.
We've done with the snapshot initially. Connection breaks. To lose the connection of the snapshot. Does it need to be covered over the snapshot?
When you do the initial generate geodatabase, yes, it'll know it's not got the complete, and you just have to call generate geodatabase again, and it'll start from it won't start from where it left off. It'll start downloading from the start again, but you just call generate geodatabase again. There's another question here. Okay, so the question, this is a good one actually. The question is there a way to secure the geodatabase so you've got a situation where you've got encryption or security at rest, I guess. Not at the moment, but it's something that's increasingly coming up in conversations with customers. They want their data secure, and so we are considering how we're going to do that. Okay, what time is it? I think we've got time still. Yep, question?
You mentioned the difference between MMPK created with Pro and on the server.
Mm-hmm.
We haven't created them with Pro because they have better symbology. Is that changed now? Are they equivalent?
Okay, so the question is, I talked about packages and offline maps created with Pro compared with offline maps created with server. And the gentleman said they use Pro because you get better symbology compared with online. That is true. Pro symbology model is richer, and Runtime supports the Pro symbology model, so that can come across. And online's is simpler. And that's still the case. The good news is that the online or the JavaScript team is starting to adopt the cartographic information model. And so we'll have one information model for cartography that works in Pro, in Runtime, and in online. Now that's a development effort underway. They're hoping, I was talking to Jeremy just the other day, they're hoping to have that available in the JavaScript API by the summer release. So you'll be able to see, the most common use case that we get requested for that is the advanced military symbols that you can create in Pro and read in Runtime. You'll be able to create them in Pro, read them in Runtime, and in June, you'll be able to draw them in JavaScript, which is the first time they've ever been able to draw these types of symbols. And then I think the goal is by the end of the year for that advanced symbology to be available in online and in the web map. And that's when the symbology models, there'll still be subtle differences because of the environments we run in, but they'll be much, much, much closer. Okay, we've got time for 2 more questions. The question is, when it's syncing, does the map stay responsive, or is it happening in a different thread? It's all happening asynchronous, so it's happening in a different thread. Yep. And there was another question here. No? Oh, question at the back. Okay. Okay, I've got a very quick answer for that. It's not supported. So the question was on snapping. Is it supported? It's not. it's come up a lot this week already. And so the team is already starting to think about how they would add snapping capabilities into the sketch editor. And it's not going to be as sophisticated as the snapping you have in Pro, but it will be some basic snapping onto the lines or vertices and things like that.
The other one is working with related non-special data. Are there any limitations?
Okay, the question is working with related records, sort of non-spatial data. We do support related records. In fact, there's a little bit more control over related records and attachments. And by default, if you synchronize, if I recall this correctly, if you synchronize your map and say, give me all the edits, or synchronize my edits, it doesn't by default synchronize the attachments. But you can override that. Same with related records. It's all supported. Yeah. Yeah, you just have to set, when you, on the sync task, you ask the sync task to go and fetch its default parameters for the sync operation. Once you've got these default parameters, you can start changing them, and you can say, well, actually, I do want to synchronize my attachments. But typically, if there are lots and lots of very large photographs, and all you're really desperate to get back to the server is the geometry edits, or some of the attribute edits, and you don't want to upload the photographs until you get a Wi-Fi connection, then typically you hold your attachments until you get a good connection to the network, and then you can upload your attachments. But that's all controllable through the API. Okay, thank you very much.